Okay, let's dive right in. We've all heard about the incredible power of modern AI, right? I mean, it's doing everything from generating breathtaking images to predicting how proteins fold. But what if I told you that for all its power, it has this one massive critical flaw? A flaw that could make it completely untrustworthy, maybe even dangerous. So, this big issue, we call it the black box problem. The most powerful AI systems we have, like the deep neural networks behind all these amazing breakthroughs, are often totally opaque. They spit out an answer, but they can't tell us how they got there. We can see what goes in, we can see what comes out, but everything that happens in the middle is a complete mystery. And look, this isn't just some academic curiosity. Think about this for a second. An AI looks at a patient's data and flags them for a really serious disease. Amazing, right? A powerful diagnostic tool. But then the doctor asks the AI why it made that call, and it's just silence. In high-stakes fields like healthcare, not having an explanation isn't just a bug, it's a fundamental failure of trust. It's a deal breaker. To understand how we can possibly solve this, we actually need a quick history lesson. You see, for decades, the world of AI has been dominated by two major and often competing philosophies. You can kind of think of them as two warring families, the symbolists and the connectionists. On one side, you've got the connectionists. Their neural networks are the engine behind today's loud revolution. They're incredible learners. You just throw tons of data at them and they figure out these complex patterns. But as we know, they're a total black box. Then you have the old guard, symbolic AI. This approach is built on clear, human-readable logic and rules. It's completely transparent, but it's also kind of brittle. It can easily break when it faces the messy, unpredictable data of the real world. So for years, that was the choice. You could either have a powerful but opaque system or a clear but rigid one. But what if you didn't have to choose? What if you could end this war and, unite the two families? Well, that is the incredible promise of this new paradigm, the neurosymbolic solution. Neuro-Symbolic AI is exactly what it sounds like, a hybrid approach that literally combines the best of both worlds. It merges these two seemingly opposite ideas. It uses neural networks for what they do best, finding those subtle, hidden patterns in raw data. And then it uses symbolic systems to reason about those patterns with crystal clear logical rules. It's like having the sharp perception of a neural net combined with the rigorous logic of a classical computer program. And this combination is an absolute game changer. First, you get that enhanced explainability and trust because we can finally see the AI's reasoning. It's way more data efficient because it can use existing knowledge, like the rules of physics or medical guidelines, instead of having to learn absolutely everything from scratch. This also helps it get better at new tasks and makes it way more robust and reliable. Okay, this all sounds great in theory, but does it actually work in the real world? Let's take a look at a fantastic test case from a scientific study by the National Institutes of Health to find out. So the researchers set up this head-to-head challenge using the famous PIMA Indian diabetes dataset. They took a neurosymbolic model, a special kind called a logical neural network, or LNN, and pitted it against a top-tier traditional AI model. The question was simple: who could predict diabetes more accurately? The results were pretty stunning. The neurosymbolic model didn't just match the traditional one, it blew it out of the water, hitting over 80% accuracy. This just shatters that old assumption that you have to trade away accuracy to get explainability. The neurosymbolic model won on both fronts, period. And here's the real kicker. The researchers could literally look inside the model and see exactly why it made its predictions. The model produced these clear, logical rules that a doctor could actually read and understand, rules that made perfect sense with established medical knowledge. The black box was finally cracked wide open. So, what does one of these rules actually look like? Well, it's about as simple and logical as you can get. Step 1, the model checks for a high glucose level. Step 2, it checks for a high BMI. Step 3, if both of those things are true, it concludes there's a higher risk of diabetes. It's an explanation that is both computationally powerful and totally humanly understandable. And this breakthrough isn't just staying in academic labs. Not at all. A whole new wave of startups is already taking these neurosymbolic ideas and running with them to solve real-world business problems. In the US, you've got a startup called Symphony that's using this approach for drug discovery. They combine a neural network's ability to dream up new molecules with the logical reasoning of symbolic AI to figure out how to actually make them. It's dramatically speeding up the search for new medicines. Then jump over to France, and you have Ripple-Tide building AI sales agents. These agents use language models to understand what customers are saying, but they also apply hard-coded business logic and rules to qualify leads and follow a sales playbook perfectly. It makes them both smart and incredibly reliable.
And in the Czech Republic, Lakmus AI has built a simulation platform for market research. Their hybrid AI can simulate how a target audience would make decisions, giving companies fast, explainable insights into consumer behavior without having to run massive, expensive surveys. So, what does this all add up to? Well, we're seeing a really fundamental shift here. By combining these two great families of AI, we're starting to build systems that don't just mimic human intelligence, but are actually taking steps towards a form of human-like reasoning. So the ultimate takeaway is this. Neurosymbolic AI directly attacks that black box problem head-on. This hybrid approach lets us build systems that are just more trustworthy, more robust, and more efficient. It really is a critical step away from an AI that just recognizes patterns and towards one that can actually reason. And that leaves us with this really fascinating final thought. For years now, we've been building these incredibly powerful AI tools that we can use. But with the rise of these new neurosymbolic systems, are we finally on the verge of building an AI that we can truly deeply understand?